Welcome everyone. Here are the questions that we are going to go through. Details are in the description. Let's get started. An electrophile is an electron pair acceptor. Sulfuric acid, H2SO4, is an electrophile in this reaction. Two reactants combine to form a single product in this reaction. The name of the mechanism for this reaction is electrophilic addition. Here's the next question. It is a very good idea to memorise mechanisms. They always come up on exams. Draw the reactants out first of all. We will use curly arrows to show the movement of electron pairs. This is linked to bonds breaking and bonds forming. Oxygen is much more electronegative than hydrogen. There is a partial charge on the OH bond shown with delta plus and delta minus. The carbon-carbon double bond is a region of high electron density. The carbon-carbon double bond breaks, leaving a single bond, and a CH bond forms. This is shown with the curly arrow highlighted and gains the first mark. An OH bond in sulfuric acid breaks, both electrons go to the oxygen atom. This is shown by the curly arrow highlighted and gains the second mark. Before we draw the intermediate, we have to decide if the hydrogen bonds to carbon 1 or carbon 2. Both can happen. This leads to two possible products, a major product and a minor product. We will discuss major and minor products later. At this stage, if you are not sure, draw either. You would only lose a maximum of 1 mark if you draw the wrong intermediate. A carbocation is a carbon-containing species with a positive charge. The positive charge is on the carbon atom that is only making 3 bonds. The correct carbocation intermediate is highlighted there for the third mark. The final curly arrow shows a CO bond forming. The arrow must go from the centre of the lone pair on the oxygen atom to the C plus carbon. The lone pair of electrons on the oxygen atom must be shown with 2 dots. You must also show the negative charge on the oxygen atom. The correct mechanism is shown in full here. I have also added the final product. To answer the next part of the question, we need to think about major and minor products. Both the alkene and the electrophile in this reaction are asymmetrical. If hydrogen bonds to carbon 1, the intermediate highlighted here is formed. The C plus carbon in this intermediate is bonded to 2 carbon atoms. This is a secondary carbocation. If hydrogen bonds to carbon 2, the intermediate highlighted here is formed. The C plus carbon is bonded to 1 carbon atom. This is a primary carbocation. Primary carbocations are the least stable, then secondary, and then tertiary. The minor product is formed via the least stable carbocation intermediate. The minor product is shown there in blue, which gets the mark. The final step of the mechanism to show the formation of this minor product is shown in red on the left. Here's the final part of the question. To explain why the product shown in your answer is the major product, we would have to say that the minor product is formed via the least stable carbocation. You could also say that the major product is formed via the most stable carbocation. That gets the first mark. For the second mark, we need a little bit more detail about why certain carbocations are more or less stable. Due to the inductive effect, the secondary carbocation intermediate is more stable because the C plus carbon is bonded to 2 alkyl groups. One final and very important note. The inductive effect explanation has now been disputed. Questions in the future will not likely require you to explain the stability of carbocation intermediates in terms of the inductive effect. Here are the question details. What type of organic reaction mechanisms do you find the most challenging? Post in the comments. Take care and good luck with your studies.